So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 259, and in this video we continue with our virtual function specifier, and we stopped here with this example. We finished this one and now we start with this example here. I go through this one and let's get started. It says here, for every virtual function there is a final override, and this final override I talked already in my last video what this means, and here we will talk it again, but with an example to see how this works in this example here. And let's continue, which is executed when a virtual function call is made. So with other words, we have to call a virtual function. Most time it will be the first one in the base, but not all time. Can be also called in the struct B. We will see this later a little bit. And then it says here a virtual member function, shortcut VF of a base class base, is the final override unless the derived class declares or inherits through multiple inheritance another function that overrides VF. So what does this mean? So first of all, let's start here with the first line. It says here struct A. It's just the definition of a struct. We have here the compact style, which means all it's written in one line, and the struct has only one virtual function here, and we talked about it. A virtual function is just a normal function with the start word virtual in front. And here the second sentence says this is the final override here only if there is not a derived class which inherits this struct A and overrides this F. So if we have nothing like this one here, think about this was not here, then this one will be used. But we have here a struct B, and this struct B is inheriting from A. This one is then becomes our base, and important, we have here a function called F with the same name. We had talked about this in our last video. It fulfills these requirements here, which means this function here will become automatically now, because it was already introduced here, this function will become virtual. It is not declared here as virtual, but it is from compiler considered automatically virtual, and important, it is also considered as an override. It is also not stated here, and that's that one I talked in my last video. It's better to write for best practice purposes here an override, for example like this one here. But the point is, this override is optional. We talked about this as well. You can omit it, and you can see they don't write it here override, but this is an override. That's very important that we have to learn this, and we have to distinguish that, because in code you can see some people write it, some people not, and we have to understand how the compiler is considered this. And the compiler says yes, this is an override. This is even a virtual function also if there is not a word virtual, and we have to know this. But again, best practice, just write here override, because that makes our readability easier. When we see here this function, we would assume, oh, is this just a normal function? But when we see here an override, it is probably a virtual function. Well, it has a parent, it was inherited, and then it's an override. So that makes our life easier when we write it this way with this key, with this word override behind this one. But again, it is just optional. So in this case, they don't use it. We have to know it. And now, again, when we start here on top, you can see, first of all, it is realized from the compiler this function AF here, this one here, is virtual. The compiler note this, and in my last video I said there will be created normally a virtual table. We will talk about this one more in detail in another future videos, but right now you have only to know that this one will be considered the start point. And important is then the compiler checks, like in the text here, if this struct A is inherited by a derived class. And I showed you right now, yes, this struct B is inheriting. This is our inheriting section where it says, yes, I inherit from A. And now this function is overwritten. And now let's go back to this word final override. Final override means because I have here a struct B, this one is the final override and will be used when we call this function f. What I mean with that is if you create an object, for example, they are creating also an object, but they already create an object for this one. But let's say we create an object for b, and then you call from b ef, which means I create an object for b, I call this let's say ef, for example, here, and then what happens is the compiler is checking first, like we know it, we learned it. The compiler will go and create first the parent class because this one is not complete. We learned this inheritance. Like what I mean with that is, remember when we try to create this object b, the compiler checks first if this struct b is complete. So with other words, it checks if there is a inheritance, for example, and then it says, oh, I see here this inherits from a, then the compiler knows automatically this struct is not complete, then it goes up, and then it goes to this inherited base class, parent class, and then it checks if this base class is complete, and then it's the compiler says, oh, it inherits nothing, so this one is complete, I can try to construct it, and then it says here, I see the function f here is marked as virtual, so the compiler is creating a virtual table here and set this one as a start point, and then it applies the rules what I just mentioned. It's if this one has no other override, then it will use this one, but again we see struct b here when we go back here again after the creation, and then it creates this one, and then it checks, oh, here is the same function, and now this one is my final override, which means when you call it, it will use this one here. And yeah, we will see this one a little bit more in detail. Let's continue here with this example. So it says here then AF is virtual. Okay, we check this up. BF overrides AF in B. That was what I just explained. F is overridden here, and this one will be used because it's an override. Then let's go to the next example. Again, we create another struct and we check again inheritance, but here important is it is inheriting not from A, it is inheriting from B. And we talked this in our last video. This is called indirect inheritance from A. Why it is indirect inheritance from A? When I call it here inherit from B, because B is inheriting from A. That's why it's indirect, and this virtual function call works here too, which means when we have again a function f and it goes again what I explained to you before, the compiler goes up, it checks if this complete, now it goes up, it goes complete, it tries to construct then it sees A is complete, and then it construct A, and it construct also this function, and then it checks, oh, virtual, it marked this as a start point, then it goes back to B and sees, oh, this is an override, and this is then also virtual, and then it goes back to C, and then it finds again F, and then it said, oh, this is also an override, and this is also virtual, and then it marks this one as our final override. Okay, I hope so far it's clear. And the compiler make this all time the same, but let's see. One more thing I just forgot to mention here. We have this word virtual. Never confuse this virtual keyword with inheritance with this virtual keyword, because this virtual is used for function calls, virtual function call, and this one we already talked about it. It's for inheritance functionality, and the inheritance functionality was with virtual that it is just creating one base, but this base will be shared, and you can see here is another struct created, and this other struct, it has also inheritance and also virtual inheritance here in B, important, which means this one and this one, they share the same base. They are not creating separated base, so which means you have to be careful here a little bit more. If you handle variables, they will be overwritten in the order which was the last called, and so be a little bit more careful about this inheritance virtual bases because they share the same part when you are programming something. Okay, then we have here, for example, the body of the struct D. Interesting is here, you can see there is no function f now, which means the compiler says, okay, here is nothing override. And here in this comment, you can see already it says D does not introduce an override, which means nothing like this one. And BF is final in D. And final, again, where is the final override? It says here in BF, which means B is here, F is final in D. So why is this final here? The question is, why is this final here? I just showed you the compiler goes here, right? Here, right? And here. But here it says in D, which means BF. BF is here, final. Why? And the answer is, careful, you have to check this inheritance. This one, struct D, inherits from B, right? That's very important, from where you inherit, and it inherits from B. So with other words, this struct D don't know that there is a struct C or something like that. It inherits from B, and in B it finds this F again and again, like before I mentioned, when we inherit in general, it would construct this first, mark this as a virtual, it goes back to B, it finds F, this F here will be replaced with this override, and then struct D would not go, also it would not go down more, because struct D is just the final inheritance point. So it's not inherited from C. So careful about this one. So it's important from where you inherit here to determine where the final override is. That's can be tricky sometimes, but yeah, that's why we make this example, to see this, and we will train this. Of course, you have to train this as well. But let's continue here. Let's see what happens here with the next one. So it says here again, we create again a struct E, and important again how we inherit. In this time, we inherit from C, D, and what I talked like before, they have the keyword virtual here, but this virtual is only important for creation of inheritance. So this one share the same base. And let's see what they say here. E does not introduce an override, which means this here has no override, because this one we have not talked about. This one, this has again, you can see this is only to make AF visible here for lookup. We have not talked about this one. And then but let's check what the final override for this one is, because we don't need an override like this one. Here we have not introduced any override as well, here also not. And here was BF, and they say CF is final in E. Let's check what happens here. C is here, F is here, and it says this one is the final override. Even I have here CD, but that makes sense because we have here C, we have D. D has no override, but C has an override. So it makes sense that CF is our final override, right? So with other words, the compiler would use this one here, whatever comes here in the body of this CF. All right. And again, don't worry about that. We have not talked about using, or I don't know, but I think we have not talked about this one in detail. Using means just like it says here, visible lookup. This it can later we will talk about hiding visibility or accessibility, and in this case, it is hiding this one here on top. Anyhow, and it says I make it visible, but we will talk about this in later when we use come to this part here. It's not so important right now. Important is that you understand here the final override. And let's go now to an example, and our example here is we create an object of E. So we create here this one, an object of E, and we have to know this one is inherited from CD. Then you have to know C and D is inheriting from B, and then in virtual and then you have to know B is inheriting from A, and this one is in here, is our A is our virtual class, so it will start from here. Okay, the start point is here. We have, and this one is marked as virtual. Perfect. We have a function, and then we check this out. So interesting is now I'm calling e.f, the function f, and you can see here now this visibility here, this name lookup. You can see this one here is not visible, and they are using, but careful. Why I can call here ef? What do you think? What is the real reason? And the real reason is very simple. We already talked about this. They are using here structs, and struct access specifier in general is public, which means this one is public. This inheritance, there is an invisible public. This one is virtual but still public, invisible. We have talked about this. Here there is an invisible public. This one is public, this one is public, and this one is public, and so on. All are structs, all are public. They have not specified any access specifier. And when you get used to that, that becomes more and more easy for you. But the reason why you can just call here, it's just because it's public. And this one is more for the compiler. We will talk, like I said, we will talk about this one in special case. So, and it says here now, when we go into this the documentation here, it says here virtual call calls CF, the final override in A. So the question is now why it is calling CF. Where is CF first? So CF is here, F is here. So it's calling this function here, what is defined here. So it's what is defined here, that will be used with that one. So it is not calling this one or this one. And the answer is very easy. That was what I explained you before several times now. The compiler goes all time on top. It checks, this is our start point. This is not our final override. It goes here. It checks again. Oh, this is not our final override. It goes here. It checks. Oh, this is our final override. The question is, why is this our final override? And the answer is because struct D has no override. Struct E has no override, which means this one is our final override. And here is something interesting. What is that one? So, okay, here on the comment section it says already what it is, but careful, we have already talked about this as well. We have here E.E, which is a direct call, more or less, more specified what you want to use, and then important is this one here, and then calling the function non-virtual call calls AF, which is visible in E. So that is interesting. Why is this interesting here? So what happens is here, it goes here in E, and then it goes here on E again, and then calls F. But why is this a non-virtual call? I mean, you can see, why is this a virtual call? And why is this a non-virtual call? This is the question here. And we talked about this. So look, this we have not talked about this in detail, but the last sentence here, it says here, there is something called a qualified or unqualified. In this case, it's a qualified name lookup, and it describes here that is if the function name appears to the right of the scope resolution operator. And that was here also this example here. It's the same example here. You can see we have a call. We call it here. We choose from where and scope resolution operator, and this one is the right side, and then it's a non-virtual call. A non-virtual call means most time it is not following this thing what I all time explained to you. It is not just starting here on top and then it checks if this one is in final override. It checks not if this is in final override. So when you see something, this one which is not a virtual call, it is not checking all time this override what I just explained to you here. It is skipping all this part. It is just taking what it finds directly. All right, I think I stop here with this part, And in the next section, we go here through the other parts as well and see what we find here and not. All right, if you have any questions like all time, write in this comment section, and have fun, good luck, and never give up like all time. Bye.